Hello and good afternoon. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This afternoon's video tutorial is going to be, again, kind of closing our conversation here with two video tutorials, Discovery Activity number 7 and Discovery Activity number 8. Again on EIGRP, and we're going to be focusing now in this discovery activity, as you can tell by the addressing that we've got here, on IPv6. So in other words, sometimes you'll hear it referred to as EIGRP v6. And so prior to this, all of the topics have been EIGRP for IPv4, where the transport protocol as well as the passenger information is IP version 4. And now we're going to be taking a look at what happens when our transport as well as the passenger is IPv6. And so in this activity here, we're going to see that IPv6 is not much different. Really, it's just instead of saying IP, we say IPv6. So let's jump onto the branch 2 router here. And we're going to go from user exec into privilege exec, and then into global config. And one of the most important things, I'm actually going to go ahead and type it incorrectly first. If I were to say IPv6 router, if I do a question mark, you can see that this is pretty much how you fire up RIP, OSPF, and EIGRP. And remember, we've already seen RIP, and I should say RIP-NG. We've already seen RIP, and now we're seeing EIGRP. So they all start with that IPv6 command. So if I were to say IPv6 router EIGRP 100, we should receive an error message, and we do, telling us that IPv6 routing is not enabled. Remember, by default, IPv6 unicast routing is not enabled on the Cisco iOS platforms. And maybe that'll change one day as IPv6 becomes more prevalent. But as of right now, IPv6 is disabled by default. So you need to make sure you put in that IPv6 unicast routing. And then we can come back with the IPv6 router EIGRP 100. So now that we've got that in here, let's do the question mark and take a look at the options we have here. And one option I want to call to your attention immediately that's missing, and let me, now that I know where that minimizes itself to, there's something missing here between neighbor and no, and that is the network statement, right? Remember, with IPv4, that is how we would enable the EIGRP process on an IPv4 interface, as we would say network 192.168.10.0. And then if that interface fell within that network address range, then EIGRP would start on that interface. With IPv6, there is no network command. Now, some of these commands should be very familiar, right? We've got this EIGRP option where we can set the router ID. We've got our variance command here. We've got the timers if we wanted to adjust our timers. But again, there is no network command. And so that raises the question, well, then how do we enable EIGRP for IPv6 or EIGRP v6? And we have to do it under the interfaces. But before we do that, we're also going to notice, if I say do show IPv6 protocols, you can see we have EIGRP v6 running here. And we get the same information we do with v4. We see the autonomous system number. We see what the composite metric values are set to. And then we get down to the router ID. And it says no usable router ID found. Now remember that EIGRP for IPv6 is still going to use an IPv4 formatted. I got to make sure I'm clear about that. An IPv4 formatted router ID. Now, it looks like an IP address, but it's not being used as an IP address. It's being used as a router ID. So we don't have one. And again, the process is if I manually configured it with that EIGRP router ID command, that I could manually enter the value in dotted decimal notation. If this is not done, then we go to the highest numbered, and by numbered I don't mean like loopback 10 is higher than loopback 5, but the highest IP address, the highest numbered IP address loopback address. Then we go to any interface that is up. Now, these are obviously brand new routers here that are being simulated. So do show IP interface brief, and there is not a single interface that has been configured on these routers with IPv4, loopback, physical, or otherwise. And that's why we're being told there's no usable router ID found. So in order to remedy that, and I think we might already be in there. So if I were to say IPv6 router EIGRP, and I think we used 100, there we go. So we need to go ahead and say EIGRP, and here's where I can define it as a stub. I can set the event log size. I could say log neighbor changes, log neighbor warnings if I wanted to see information when there are any events that take place on the neighbor. But then we can also say EIGRP router ID. And this is where I, again, put in a 32-bit dotted decimal value. And again, it's not being used as an IP address. It's being used as the EIGRP router ID. So now when we say do show IPv6 protocols, you can see that the router ID is now clearly defined. And remember that router ID, what is it used for? Exactly, it's used as a loop prevention mechanism. And you cannot have duplicate router IDs in the same EIGRP domain because EIGRP will recognize if a router sees its own router ID, it will be under the impression that a loop has formed and it will not install any of the routing updates that it might be receiving from the neighbor in question. So far, everything is pretty much straightforward. Instead of typing router EIGRP and then AS100, we're simply typing in, again, preceding it with IPv6 because we're doing EIGRP for IPv6. And then we say router EIGRP 100. And that is it, right? So now that we know where the global configuration section is and how to create that and set the autonomous system number and the router ID, now we need to enable it on some of the interfaces that we have. So if I said do show IPv6 EIGRP interfaces, you can see that it's not running on any interfaces. And again, what's the only difference between that command and the command when we run EIGRP for IPv4? Exactly, I would say do show IP EIGRP interfaces, or do show IP EIGRP neighbors. So do show IPv6 EIGRP neighbors. So again, the commands are almost identical with the exception that instead of saying just show IP, you say show IPv6. So let's continue. We're going to enable the EIGRP interface, or EIGRP process under the interface Ethernet 00. And to do this, we simply say IPv6 EIGRP and then the autonomous system number. And that's it. So now when we say do show IPv6, and you can see we have an adjacency that popped up there, EIGRP interfaces, we are now running, again, the output is identical to the output for IPv4. If I say do show IPv6 EIGRP neighbors, you can see it's, again, identical output. The difference being that the adjacency is formed via the link local IPs. It's not the unique local address or the global unicast address across which the adjacencies are formed on the links when we're running IPv6. They're actually established using the link local addresses. So now let's go into interface loopback 0, and we're going to go ahead and enable IPv6 on that interface as well. So again, we can recall that command IPv6 EIGRP 100, and that starts the process on the loopback interface, which is going to result in the loopback interface being advertised via EIGRP. And again, do show IPv6 interface brief? And we do have addresses on the loopback interface, but take a look at that link local, right? Not the friendliest of link local addresses. So what I could say is IPv6 address FE80 : and this is branch 2, so I'll just say : 2 link local. So now when we look at that output again, that's a link local address that we can handle a little easier than the EUI64 generated version up above. All right, so what interfaces is EIGRP running on? So now here's the question, right? This isn't part of the exercise, but let's make it part of the exercise. Can I establish an adjacency over that loopback interface with another router? No, I can't, right? So what is it that I would probably want to do here? Because EIGRP is not going to be sending hellos and things like that, but again, it's not a bad idea to simply go ahead and say under the IPv6 EIGRP, or I'm sorry, IPv6 router EIGRP 100, to say passive interface default, and then say no passive interface, and this is the interface across which I want my hello messages to go, and then leave the loopback interface as passive. So do show IPv6 protocols, and you can see we have two interfaces on which the EIGRP process is running. One of those interfaces, that loopback interface, is passive, and there's nothing wrong with setting that interface to passive because it's still going to be advertised, right? Still going to be advertised out. Okay, so now we are on step 5, I believe, and yeah, let's go ahead and take a look at step 5 here. So on branch 2, if I were to say do show IPv6 EIGRP topology, take a look at that. Exact same command, simply with the IPv6 instead of saying IP. And we get the exact same output. You have your successor route, which is in the passive state. We've identified that there is one successor, and the successor being the next hop router, and that is the address there, or via that interface to get to the next hop router. I'm sorry, this interface, that IP address. And then we have the feasible distance as well as the computed distance, which at this time is the same as the feasible distance, and then the reported distance coming from that successor, right? And other than that, the table is pretty much the same. Sure, we've got global unicast addresses here, we've got link local addresses here, but again, the output is the same. Not much has changed. All right, so excuse me. So in terms of the feasibility condition, none of that changes. So the feasibility condition, the rules are the same. You can use the variance command, and the rules are still the same. You can do summarization, and again, the rules are the same. And so it's very, very much like EIGRP for IPv4. Let's take a look at the routing table. And again, it's do show IPv6 route, and not router. Do show IPv6 route. And actually, let's trim that down to just the EIGRP information. And so there's our EIGRP information. We see the administrative distance for IPv6 routes in EIGRP is still 90 for the internal. It's still going to be 170 for any external information that was redistributed into the EIGRP process. But other than that, the information is the same. So on branch 2, let me see if I can ping. Let's go ahead and try to ping, and we'll say do ping 2001 db8:0 colon, what's that IP? :1::1, and I'm going to source it from my loopback 0 address. All right, so I've got reachability across the WAN, and I'm able to ping the 2001 db8:01:1. So in order to show how summarization works, it works very much the same way. If we go back to the diagram, it looks like we're going to be doing this on branch 1, who clearly we just pinged. What address did we just ping? 2001:1::1. So this segment right here, the loopback 1 segment, we have full reachability to that segment. So now we're going to advertise a summary of db8:00, 1, 2, and 3. And so this is actually going to be pretty straightforward. So it starts on a 0 boundary, and that's going to make it easy. So we have a contiguous run here in the interesting hextets starting at a 0 boundary. And so a quick shortcut, I'll do the full summarization, but a quick shortcut here is that when we take a look at this, 264s, when we have a contiguous set here that we're going to summarize and it starts at a 0 boundary, the 264s are going to make a 63/63. So we would have 2/63s out of this, and 2/63s makes up a /62. So, and that's a real quick shortcut that you can do. And starting at that 0 boundary, my guess is we're going to be 2001 db8:0:0:/62. But let's check it out. So we're interested in this hextet here. because that's where we first have our change taking place from 0 to 1 to 2 to 3. So let's go ahead and set that last hextet up. Now, in hex, that last hextet that we're looking at, it's using the rule of zeros. And so it's shrinking the hextet down, condensing it, and only showing you the last hex character. I almost said numeric character. The last hex character that's there. And you got to remember, those are hexadecimal characters that we're seeing. Those are not integer values. They're hexadecimal characters. And in hex, there would be 4 characters in there, and it would be 0001, 000. Sorry, 4 hex characters in there. I keep seeing numbers. 0003 and 000. Wait, I forgot 0000. All right, there we go. So we'll get rid of this. All right, so that's actually what is in each of these 4 hextets. We just dropped all the leading zeros to condense the representation of the address. Now that we have this, we have to go from hex to binary. And so to do the binary for the first 3 hexadecimal characters is extremely easy. Each one represents 4 binary digits. And so 0 is just simply all zeros. So if each of these hex characters is all zeros, how many binary bits, or binary digits do we have in addition to the first 16, 16, 16? So the first 48 all match across all these addresses. And then we have 52, 56, 60. So now we're down to that hex character there. Well, let's bring it down here. So 0 is, as we've already seen, it's all zeros. 1 in, or I'm sorry, the hex character 1 in binary is 0001. The hex character 2 in binary is 0010. And the hex character 3 is 0011. And now, where are these no longer the same? It's right there. So we add 60, and then we add these last 2. So we know the prefix length is going to be a /62. So it does check out there. And then what is the value going to be? Well, what is the last value, or what is the only value turned on here? Exactly, there are none. So it's going to be 0. So we are looking at a summary of 2001 DB8 0 0 /62. That will be the summary to represent loopback 3, 2, 1, and 0. These 4 network segments here. And again, these loopbacks are simply simulating what would be physical interfaces that are coming off the back of this router. And there could be a switch here and a bunch of PCs plugged in, and this is also a switch here, and everybody's IP'd in this /64 range, and they use those router interfaces here in order to reach the WAN segment and get to headquarters or over to branch 2. All right, so the summarization is done. Now let's go ahead and let me clear the screen here, and we're going to jump back onto the command line. And again, it's on branch 1 where we're going to be doing the summary. Now remember, with EIGRP, it's distance vector. You can summarize anywhere, anytime, for any reason, irrespective of whether or not you, the router, when I say you, I'm talking about you, the router, doing the summarization, irrespective of whether or not you are the source of that routing information. And in fact, if I were to come over here to HQ right now and say show IPv6 route EIGRP, you can see that I actually am receiving, there's the 00, the 01, 02, 03. So I'm receiving that information, and we know that I'm not the source of that information. I'm the recipient of that information. And come over to branch 2 and say do show IPv6 route EIGRP. Branch 2 is also receiving that information. So what if I wanted to do the summarization on the HQ router? Can I do that? Well, let's see. Show IPv6, and let's make sure we get, actually, we take a look at the drawing here. I should have looked at that. Ethernet 01 is the interface toward branch 2. And so this is to prove that it doesn't have to be the source of the information, of the prefix information, that does the summary. So IPv6, router, EIGRP 100. I go into interface, Ethernet 01, and let me check that again. Terrible at remembering that. Yeah, Ethernet 01, and I simply say IPv6, and now this should start to look very familiar. Summary address, EIGRP 100, and then what's my summary? 2001:db8:0:0:/60, and I could probably shrink it all the way down to ::/62, right? I could just drop those zeros out and hit enter. So now I'm summarizing this information towards the branch 2 router, and I'm not even the source of the information, right? I received it from branch 1, but let's take a look on branch 2 now. You can see we have the graceful resync of the information. Whoops. And we want to take a look at the routing table now, and there you go. There is my /62, but let's make sure. Can I still ping that 2001:db8:0:1:1, which is what I think that was initially? And it works, right? It works great. So I still have reachability, and HQ is performing the summarization. Well, we know in the exercise that they want us to do the summary over on branch, and so we just removed it. So let's see what happens now. When I remove it, I can still ping. And there you go. All the original information's back. So we know they want us to do this over here on branch 1. So let's go from user exec to privilege exec into global config. And I should probably look at that interface. I never look at those interfaces. Ethernet 00. So remember, I'm summarizing on a specific interface, Ethernet 00, towards a specific EIGRP peer. And that command is going to be exactly the same. IPv6 summary address, EIGRP 100 2001:db8:0:/62. And so now on the HQ router, before I hit enter there, when I say do show IPv6 route, EIGRP, I'm seeing everything now. As soon as I hit enter, we're going to have a graceful resync. And we should get a message. There it is. We should see a message here. There we go. And then we say do show IPv6 route. So then the summary is picked up here, and then HQ is also going to pass that summary down to branch 2. And so again, instead of saying IP summary address EIGRP with the AS number and an IPv4 prefix, we simply say IPv6. And that's it. That's exactly how you would perform summarization with EIGRP for IPv6. Again, a nice entry-level exercise to sort of get you used to having to type in IPv6, router EIGRP, or IPv6 summary address, or IPv6, show IPv6 route EIGRP. And again, it's IPv6 as the transport as well as the passenger, so you need to have IPv6 all the way through in order to have this work throughout the environment. All right, well, that's going to conclude the EIGRP for IPv6 conversation. Now we're going to go into the name mode conversation, and I will see you in the next video.